Greetings once again. Today on the bench we have a K7500 that was sent to me because it's blowing the HOT. So these are always fun to try and figure out. Half of the time there's nothing wrong and it turns out the HOT simply just died. And you can replace the HOT and turn it on and have it be fine. But we're going to, of course, test everything, make sure nothing is wrong, and then we'll replace the HOT. We're going to put in the beefier FJL 6920, I think it is. Yeah, FJL 6920. We're going to put one of those in there instead of the original. I think it's 3688. We'll take a look and see. But we're going to put a better, beefier one in. If nothing checks bad, and we'll turn it on and see what we get. But first things first, let's go ahead and open it up. Here we go. Okay. I'm not a fan of the clear packing tape on the bubble wrap because then I can't, it's hard as hell to get it unwrapped, and then I can't reuse the bubble wrap if I end up having to cut it. It just makes it hard to open. Okay. Uh-oh. Casualty of shipping. Broken bias pot here, or drive pot. Broken red drive pot. Busted. Casualty of shipping. I'm sure these are all casualty of shipping as well. Let's go ahead and just straighten that up. There we go. And bend it away from the... Well, I think someone's already done some work. What in the shit is this? What the shit? Hey, that guy took my phone! Mr. Wizard, get me the hell out of here! Well, let's just take that off. And this off. Okay. Now, we got a blown cap here. Interesting. We've got a bulging cap. Absolutely. That is no good. The rest of these all seem alright. But I don't think that's the right... Yeah. That's the right size and rating. Interesting. I think someone's gone a little overboard with this glue here. Yeah, kind of a low hour 7500. It's not too burned up. Traces aren't bad. Traces aren't lifted. Not too bad. Not sure why this is... Someone's got this... This is like epoxy. Because I can't even move this. This is solid. So is that one. This one I was able to move. So someone's got this glue caked on here. Not sure why, but I guess we'll just leave it. Looks like a cap kit's going to be in order. And we'll have to figure out if we can replace this pot. I don't know if I have one. I think I do. And yeah, this cap is bulging, so we'll definitely have to fix that. Someone went way overboard with all this glue. And something I just noticed is that the G2 wire wasn't hooked up. All we had hooked up was the focus wire and the actual connector here that's broken. The G2 wire wasn't even hooked up. I hope it's in there somewhere. So let's set the neck board aside and kind of continue revealing this here. Yeah, here it is. Okay, just wasn't hooked up. Maybe it came off in shipping, I don't know. It appears to have a new flyback. It appears to have a new flyback, and if you ever see, well, it's on there. It's not sitting flat. It's like the leaning tower of flyback a little bit. Not sure why it didn't get put on flat, but not the end of the world. This is one that has the, if you look here, they are using a dual focus case. You can see screen, focus, and this one has no designation because this one is just, there's nothing, it's a dual focus case, but there's still only a single focus winding in there. So don't, if you ever see one of those, don't worry about it. That's how it is. Looks like someone replaced the flyback, but they did not replace the caps. Not sure why you would flyback it and not cap it, but that's just how things go. Someone's been tweaking on the shutdown pot. We'll have to see if that's an issue. We're going to remove this. Why they've got that like that, I don't know. God dang it. Man, they've got all these on there. All of this stuff is glued on. I don't know why someone would do all that. But not a big deal. Okay, let's check out. Remote board pots seem okay. This is the correct one for this board because if you notice, the horizontal hold pot is not here. That's because on the 7500 it's actually right here on the board itself. So we don't need to worry about that. So we'll set the neck board and the remote board aside. And now we've got the main board here, and you push down on the main board and lift up on the plastic piece at the same time, and then you can just lift up on one corner and it slides it right off. Nice and easy. So let's take a look if we see any more bad caps that might be the cause of a problem. Get that there. Not offhand. I don't see anything that leaps off the page at me. It looks like somebody has been adjusting the B+ pot because there's no glue on it, or they've replaced it. This is, I've never seen one from the factory that did not have glue on it, so I think someone has changed that out, and someone's been tweaking on the shutdown pot because the glue's been popped off of it and it's moved. So we might have our work cut out for us on this one. Let's check the back side. Not too much butchery that I see. Some definite iffy solder joints, but nothing too bad. I don't see any cracks or breaks or any lifted pads. There's certainly a number of iffy connections, but nothing we can't solve or reflow. Okay. Yeah, looks like someone has replaced the switch mode power supply chip as well. Trying to figure this out. So I think our first thing we're going to do here is I'm not going to bother with reflow or testing components. Let's just go right to the light bulb test. We can go right to the light bulb test. If our light bulb works, then we know our power supply section is okay, our switch mode power supply chip is okay, we can adjust our B+ to the correct, I believe around, I think if we put it to about 127, it ends up being about 117. It's supposed to be 117. I think if we put it to 125, 127-ish, we can usually get it right to about 117 once we get a full load on it with the picture tube. Yeah, someone's been replaced. These aren't original. These two caps right here, those aren't original caps. I think what we'll do is we'll just start with our light bulb test and see where we get from that point. But before we do that, I want to make sure that our resistor here reads 10 K ohm to 12 K ohm. And yep, 10K. So That, again, if this reads 10K, like it's supposed to be 10K, if it reads 10K, it can usually go up to between 10 and 13K, and this will still operate. But in circuit, if you read 10 to 13K, that usually means that everything in this section is good as far as not being shorted or open. If you get some type of way out of tolerance reading and take this out of circuit and it reads 10K out of circuit, but way out of tolerance in circuit, then you've got something else wrong here, whether it's these resistors or the diodes or what have you. So generally speaking, if that reads 10 to 13K, you can bet that your power supply section is somewhat okay. And then the next step would be just to do our light bulb test. So the first thing, you've got L100 right here. To accomplish this L100, you lift this leg out of the circuit from L100, and then you can hook that to your light bulb and it should power on. So if we simply remove that from the circuit, which is here, right there. Is that it? Or is it this one? Am I seeing? Ah, here we go. There it is. Bend you up out of there. Okay, now it is out, and we clip on that and run that to our light bulb, and that's how we test our power supply. Alright, so let's zoom out, and we'll grab our power connector. Plug it in. All right. We're going to need a bigger boat. This will go to our light bulb. This will go to our meter. So you take a couple of alligator clips and clip on to L100 right here like this. And you can see I got 2 leads here on L100. What this does is, taking this out of circuit removes the B+ from the rest of the chassis. So by doing this, all we're testing is the B+ part of the regulation on the power supply. So that's the purpose of that. So we have one lead that will run to our multimeter to tell us what our voltage is, and we have the other lead's going to run to our light bulb. And we're hoping that that turns on. More glue on this side too. Trying to rock this, get that off of there. Okay, success. Why they do that, I don't know. We're gonna have to figure out how to put this back together, which we'll do that later. Okay, now we need a third. Do I have a third one sitting over here? Because I need one for my negative. Here we go. Nope, that's for my logic probe. Where did all of my stupid alligator clips go? Well, we'll have to use the white one here, that's fine. Alright, so if we get our meter here, we put it to volts AC and then volts DC, alright. So we clip our meter onto here for positive, and then our negative will go to the frame here. There we are. Okay, so now all we need is a light bulb, where I think I have one sitting here. I do. All right, here we go. This is a 30 watt, 23 watt actually, 23 watt bulb. So we're going to take this lead here coming off of our L100, and we are simply going to touch it to the center of our light bulb at the same time that we touch the frame here for negative to get the ground. Our light bulb should light up. So you don't need to worry about anything else being unplugged. This will tell us whether or not our power supply section is good, and we can proceed from there. We can also adjust our B+. So let's go ahead and flip our power on. So here we go, 1, 2, 3. Okay, you can see we're climbing up to 183 because there's no load on the chassis. So if we touch this to here, and then we touch this to the center, we get 128.7. So our power supply section is good, and I want to lower that to about 127. So if we simply turn this down slightly and put a load back on the power supply, we're at 126. I went a bit too far. Let's see what that does. 126.7, close enough. All right, so we're going to leave it there, and that should settle down around 117, 118 once we get this back on the tube and running. So now we know our power supply section is good. And I just noticed that it's already got one of the beefier FJL series in here. So if it's blowing the FJL series, then we definitely have something wrong with the chassis. So let's go ahead and turn this back off. And you'll want to discharge this the way you normally would. So we have all of this stuff hooked up here. We simply take one of the two leads that are attached to the L100. We ground it to the frame. There you go. And now our voltage is 0. And it's safe to handle, and we need to put L100 back in first thing, because I always forget that. So we have just verified that our power supply section is good. If we did that test, the light bulb did not come on, and we didn't get 180 volts, then we know we've got a problem with something in the power supply, whether it's the switch mode power supply chip, or the B plus pot being open, or the resistors, or R104 being open. There could be any number of different things, but the fact that we got good B plus and good regulation, it means that all that stuff should be reliable. So let's put this stuff away here. Okay. All right. Disconnect our power. All right, quick and easy test there. Let's see. So we'll put L100 back in because I always forget that, so we do that first. Make sure that lines up, and there we go. Okay. And there's that, and there is that. All right, so now it's time to do some testing to see why our HOT is shorted. And if we simply go right to the HOT, again, the HOT is this guy right here. And those component legs correspond to, let's zoom in here, right here. So if we go here to here, it is shorted. Doggone it. Okay, so now the next step is to remove it from the circuit. So I got to turn my desoldering station on here, and I'm going to cut away because it takes about 3 or 4 minutes for it to warm up. So I'm going to cut away and come back. We'll have it up to temperature. We'll suck that out of there, and then we'll test the... We want to remove the HOT from the circuit to see that if it's actually shorted out of circuit. If it is, then we know it's bad. We also want to test the pads with the HOT out of circuit to see if the pads read shorted. If the pads read shorted, then we have something on the circuit that is absolutely causing the problem. If the pads don't read shorted, then the HOT may have just failed. But I think we're going to find out that there's something shorted on the circuit because these FJL series HOTs are much beefier. So I'm going to cut away here, come back when this is up to temperature, and we'll get that out of there and see what we find. Okay, so we're all heated up here, and let's get this out of here. All right. You can turn my fan on here. Well, it wasn't secure. Look at that. So whoever installed it last time didn't secure it. And it should come right out. There we go. So, time to test it out of circuit. Yep. Wow. Okay, so we definitely have a problem. So we'll set that aside and we'll test our pads. Pads are not shorted. Interesting. Well, I think that's normal. I think these two are, it's normal for those to be shorted, if I recall correctly. I'll have to verify that, but when we have a shorting HOT, one of the most common failures is C121, but that looks like that's one of the ones that someone's already replaced. So C121 here and C119, looks like someone's already replaced those. I don't know if they're the right ones or not though. And they are not shorted. So that's not the problem. We'll have to test, yeah, D706 isn't on the 7500. There's a diode under here that sometimes shorts out, but it's not on the 7500. It looks like it's only a 7400 diode. What about this one? That's good. Very interesting. Well, we may simply just need a cap kit. But let me verify something. That's interesting. Why were those like that? So these two resistors were touching each other. Not sure why they were like that, but these two resistors here were having a little affair with each other. You can see right here, these two, if I touch this and this, that's shorted. There you go. I guess it's supposed to be. Is that actually... See, that was there. Okay, so, well... Huh. Well, there's a 43 ohms across here to here. Must be going through a different resistor. Yeah, 48 ohms. Alright, well, disregard that. Let's test these capacitors here. Open, open, and open. Okay, so it's not those capacitors. They're not shorted. R303 is not going to cause HOT to go out, but we can test it. That's good. 1.3. D302 is down in here, and it's good. Alright, so the next step in our evolutionary process here is we don't have R760 or 765. Those are usually the culprits for a blowing HOT on a 7400. We don't have a Q708. This resistor here, I'm pretty sure, is for our vertical deflection, so it's not going to be that one. Well, let me verify on another chassis if these two are supposed to ring together. I think that they are. If they are, then we'll have to proceed on and maybe just do a reflow and a cap kit and then cross our fingers, because I don't see anything immediately that would cause the HOT to go out. It's none of the film capacitors here. I don't see any bulging caps. None of the normal culprits are installed on the 7500. Let's look at these components off of C121. C121 here is usually the cause of the HOT going out, but I'm wanting to look and see what these resistors that are part of that circuit read here. And let's get this in the frame here. We'll start here with R728, 1.12K, R732, 1K, 1.12K. Well, it's not way out of tolerance. Alright, well, let me grab a working 7500 to get some comparative readings off of, and then we'll see what we get from there. Well, I did some comparative readings against another working K7500, and I couldn't find anything different. I couldn't find any anomalies, any discrepancies, any differences between this one and the working one. So I think what we're going to do is we're going to just do a full cap kit and a full reflow, and then try it out, see what happens. Maybe maybe it's a bad cap that's dried out. Maybe it's something on the owner's end. Maybe his tube has a shorted horizontal coil on the yoke. I can't say, but I'm not finding anything actually wrong. No failed or shorted components. No resistors out of whack. No capacitors shorted. And basically, we know that there's nothing shorted on the HOT circuit because these two pads are supposed to be shorted. And my suspicions were correct. These two pads are supposed to be shorted because they're shorted on two other known working chassis. This is 1.2 ohms, that's correct. But between this one and this one, not shorted and not shorted. So there's nothing shorted on the HOT circuit that would count for this. So it could be a bad solder joint. It could also be simply bad caps. So we're gonna do a full reflow, a full cap kit, and see what happens. I'm gonna do all this on time lapse because why not? And then we will see what we get. I also checked Q703. If Q703 is bad, it won't blow the HOT, but it'll cause the board to be dead. So, but Q703 checks good. We got L100 back in the circuit. So yeah, I don't see anything right offhand that leaps out at me as the problem. Nothing I found was out of tolerance or out of whack. So let's do the cap kit, let's do the reflow, let's put a new HOT in there, turn it on, and see what we get. So cue the time lapse. Okay, all back together, full cap kit, full reflow, full inspection, neck board repairs complete, got everything reconnected. I got the G2 wire hooked back up. The socket was super loose. I just put it on there and you breathe on it, it'll fall right off, so I just squeeze it a bit to get more pressure on it. Now it's secure. I got the red drive pot replaced and set to the center and verified it's the correct reading. I got everything reflowed and secure on the neck board, main board as well. New HOT is installed and it checks good, but I'll show you that in circuit it checks good as well. So the fact that this checks good here means that nothing in the circuit is shorted. So if we go here, diode, so we touch here to here should be 0.5, 0.427, close enough. And the other leg should be the same thing. Since both of these read together, it should be 0.427 and 0.427. There you go. So if anything on the board was in the circuit was actually shorted, we would see that with this installed, and it reads good. So that means nothing is shorted. So I'm a bit at a loss as to what would cause that to happen. Now, most likely, if we turn this on, we are ready to hook this up and turn it on. If we do that and everything works, and I'll let it run for a while, assuming that it's okay. If everything operates and runs normally, we're going to have to set the B plus and verify that and our shutdown. But if everything operates and runs normally, then I think it's a problem on the owner's end. He may have a bad yoke or didn't hook something up properly or what, I can't say. But let's go ahead and get this hooked up and set up to read B plus, and make sure that our shutdown pot is set to, I believe it's what is it? Oh, is it 0.01 or 0.1? I'll have to look it up. But we'll test to make sure that that reads the correct reading as well. And assuming that it turns on, assuming our HOT doesn't go zap immediately, we'll do all the other stuff. So nothing to it but to do it. So let's go ahead and get a tube up here. And this is a 25-inch K7500. And we'll get the tube up here, we'll get our width transistor installed or hooked up or all that jazz, and then we'll turn it on and cross our fingers and see if it works. So one moment. Okay, all hooked up. Anode, neck, yoke, ground, power. No, let's do that. Anode, neck, yoke, ground, power, remote, video. And we are secure. Got the screw in there, and oh, like I always... I forgot to hook up my B plus, like I always do. We can snake this into the frame. I need my jumper here. B plus test point is right here, so we can clip onto that. Oh, sorry, it's right there. There is a little test point right there, so we clip onto that. Make sure we're good. Okay, that is good. And we simply take our positive lead here and let's see if I can do this the way I normally do. Clip onto there. Okay, make sure that's insulated. We're not touching anything. Okay, we're ready. Let's flip the power switch. See what happens. 1, 2, 3. Comes right on. Wow. 118. I was close. I put that to 127 and it translates to 118, and usually 117, 118. So I need to turn it down just a bit. We've got let's see, hold issues. Let's do vertical hold, but that's a horizontal. Vertical hold's locked on. See, there's scrolling. There's vertical hold's locked on. We need to adjust our horizontal hold, which again is this guy right here. And that's not good. That is not good. We've got hold problems. Dang it all to hell. Well, it is working. Let's see if I can adjust our B plus down to 117 here. There we go. How about that? Perfect. But we've got hold problems. Oh, dang it. It's not a connection, is it? Nope, not a connection. Alright, so let's get rid of this before we destroy something. Well, let's go back here a minute. So, I hate it when this happens because I don't have a definitive answer. Was it the caps? Was it something I reflowed? Was it something on the owner's end? I can't say. But they sent me this and says blows HOT, and we verified and tested and found out the HOT was in fact blown. But after the rebuild, it seems to be working. But I just got to figure out what's going on with this sink here. It does move when I turn the pot. Oh, look at that. There we go. I can get it to lock on there. But what in the heck is going on there? You know what? I know what's going on there. Oh my God. Oh. It's been a long day. I've been working all day and I totally blanked. This is Mortal Kombat. This is a standard res game. I need a medium res game. And I just happen to have one right here. Gosh darn it. Sorry guys. And gals. It's been a long day. Okay. Now, what's going to happen? Let's wait here. Okay. Not unexpected. Well, there you go. Holy cow. Let's turn our contrast down. Whoa, contrast down, brightness all the way down. And let's turn our screen pot up until we get our image. We won't get raster, but we should get an image here. Damn wire's in the way. There we go. Roughly there. I'll tell you what, let's turn our light out so we can see better here. Okay, now H position. There we go. H position works. And our width control, does that work? It does, because we hooked up our transistor. Without the width transistor installed, you will not have any width control. So that has to be installed on the 7500. Normally it sits right here, is mounted. Normally it's mounted right there. They remotely mounted it for some reason on the 7500. Can't say, probably for extra heat dissipation, I can't say. But there we go. So let's turn up our Contrast and brightness to roughly there. Now let's see if we can adjust our focus. Should be the middle one. Or is it the top one? Nothing's happening with the middle one. Ah, it's the top one. Ah, okay. Look at that. Ta-da! It doesn't get much better than that, folks. Look at that. Wow. All of the colors are set to exactly center. All of them. All 5 are set to the exact middle point. And that just goes to show you how when you have a good working tube, the ideal position for all these pots from the factory should be in the center. With a brand new, fully adjusted, color guns aligned and all the thing, everything brand new. Ideally, you'd have all 5 in the middle. That's exactly where they're at right now, and this looks glorious. Just perfect. So there you have it. I don't know what the actual cause of this problem was, whether it was caps or solder joints or something on the owner's end or G2 wire being unhooked. I can't say, but after the reflow and the cap kit and the inspection and the testing and everything that we've done to it, it's now fully operational. So I'm going to leave this run for a number of hours like I always do, and barring any unforeseen incidents, I will consider this repaired. So hopefully you learned something. Thanks for watching. And the next video coming up after this will be a U5000 that has vertical collapse. So that should be fun. So stay tuned for that. Like, share, and subscribe if you want. I'd appreciate it. And we will see you next time.